Please, please, please.
We'll sit on the couch.
Can I tell you something?
Yes, please.
Can we learn about toys? Cause I got a toy today.
What kind of toy?
It's a simple dimple.
Oh my God, that is so cool. Now, can you hold that? I'm gonna stop sharing for a second, and I want you to hold that toy. I want you to hold it with one hand, and I want you to hold it still.
And it's a keychain.
But if you hold it still, I can take a good picture of it. So don't move, like as still as you've ever been. I got it. Okay. So we're actually going to be able to use this. All right. Now, what's kind of cool about it, and let me now share that with you, Tessa. Now, can you say what it's called again, please?
A simple dimple.
A simple dimple. So what we're going to do is we're going to trace it. How many dimples does each of the circular pieces have, do you think?
3.
How many?
3.
Well, there are 3 circles, but how many dimples? Like, I call that little groove a dimple.
Oh,
So
how many of them?
That's one dimple. So how many dimples does each circle have?
I'm counting up all the circles. Okay, now I'm gonna count 1. Oh, they all have 2.
I don't agree. I'm going to count them differently, maybe than you.
They have 5.
Well, I'm gonna make an argument on that, and I'm gonna say
7.
Well, look at it.
One, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7, 8. There's 8.
Yes, they each have 8 dimples. Now, what's really interesting about this is they do something, and there's a special word in geometry. You're not going to believe the word. You're going to think I'm making it up. Are you ready?
Yeah.
The word is no, don't laugh. It literally is called to tessellate. And I think I may have spelt it a little incorrectly because I wanted, but it literally is. Can you say tessellate?
Tessellate.
So the word tessellate, and I think it's actually spelt with an E, but it means that things go together. So the word Tessa is like a really important word in geometry. And I can't believe that you just showed me that amazing toy. Now, what we're going to do is we're going to look at an 8-sided polygon. And we're going to look at how they tessellate, okay?
I like polygons.
Yeah, well, my favorite polygon is the one I'm going to show you right now. And sometimes my favorite polygon changes, but I think you're going to like this one.
Is this your favorite one today?
It is.
Ooh, I like that one.
You have to name it. That's your obligation.
Let me think. Can I have a clue?
Yes. The only clue I'm going to give you is that if you count the number of sides and you think of an animal with that number of legs, it's going to help you name it.
Which animal has 7 legs? What animal has 6 legs?
Wait a minute. Did you count 6?
Yeah.
Well, I think you need to count again.
1, 2, 3, 4, 5, 6, 7, 8.
So not 6,
But
but
8.
8. What is the name of an animal with 8 arms or 8 legs? Or a person who is 80 years old? Or an animal in the sea. What's it called? An animal in the sea that has 8 legs.
Starfish?
Ooh. Now, I don't know
Oh,
if
wait, they have
starfish
4, I think.
can have, no, I think starfish can have 5 legs. I'm not sure. I think it's 5. We may have to ask mom and dad about that because I bet they're knowledgeable in the art of starfish because they're quite beautiful and symmetrical. Sweetheart, have you ever heard of an octopus?
Yeah, they have 8 legs.
An
And they do it like
octopus,
it has 8 tentacles.
yes. So guess what? These are called octagons. And octagons, octagons tessellate to form this beautiful figure. Do you know that when they invented your dimple, what is it called?
Simple dimple.
Okay, when they invented the simple dimple, I am guessing that some mathematician drew this beautiful diagram and said, we're going to make something out of octagons. Now, let's kind of see how we can think about this as a simple dimple. If we draw this, we can draw 8 dimples because there are 8.
So we counted all these, and then we found out there were 8 on them. 1, 2, 3. And then now, so the scientist, maybe he just thought of the number 8, and he wanted to make something with 8 things, and then with 8 things, and then he went to work and started creating a thing out of rubber, and then he made this part, and then he made little like flowers kind of around it, and he made sure that they were 8, and then he put it on it, and then he put a hole right here and put a keychain on it.
Now, I mean, do you understand, honey, that you could actually create things like this? If you understand mathematics the way you have been practicing, trying to become an expert, look at the way we just turned these 3 octagons into a simple dimple. Now, I didn't draw a beautiful picture. I drew a good picture, okay? But it's really neat how they all come together. Now, do they separate? Do the 3 things separate or no?
I think they do.
So you can actually look at each one individually. Each one is
No, they stay together.
They do stay together. Okay, interesting. Now, let's take a look at some other shapes, which I think you'll really enjoy. So the next shape I'm going to show you has a special name, and it's called a pentagram.
Pentagram.
Now, you're going to say, oh, Mr. Kramer, that's not a pentagram. It's a, are you ready?
Yeah.
All right, so let's do this. Say, Mr. Kramer, that's not a pentagram. That's
Uh,
a
star.
That's a star.
That's a
And by the way, does it not look like a starfish?
it kind of does. Wait. They do have 5 arms.
It's called
Pen.
a pentagram.
Wait,
Now
really?
the reason why it's called a pentagram is because, now, are you able to tell me how many points this particular star has?
Yeah, there's 5.
Mm-hmm. And do you know that in
3
Latin,
plus 2 equals 5.
wow, yes. So do you know that in Latin, the word penta means 5?
5.
So since there are 5 points, we call this a pentagram. Now, here's a bonus question. If we call this a side of the pentagram,
Like the
you see it?
sides stay in a boat.
Yep, and that's a side, that's a side. Each one of these is called a side. I don't want you to answer fast. I want you to answer slowly. How many sides has a pentagram? Remember, I want you to answer slowly. You can think about this. You can think about a special way of doing this, a special algorithm to do this. But the question is, how many sides has a pentagram?
Eight.
Well, how did you calculate
I
the 8?
counted the sides. So 1, 2, 3, 4, 5, 6, 7, 8.
I think you should keep counting.
9.
I think you should count again.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.
Yes. Tessa, do you know how we know there are 10? Because if there are 1, think about how many points there are. Didn't you say that there were 5 points to the star?
Yeah. Wait,
Well,
there's 6.
Tessa, 1, 2, 3, 4, how many?
5.
And what is 5 times 2?
5 times 2. 3.
So you think that 5 2 times, 5
Oh,
2 times.
10.
Yeah, Tessa, 5 2 times is 10. Now, Tessa, you just found out that it has 10 sides. And we know this. Now watch this, Tessa. I don't like counting by ones. because I think there's always a better strategy. But if we did count by ones to check our answer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the way better way to do it is to literally look at the number of points and then do what?
Wait, I noticed something. There's 2 on each one.
Yes, that's why we did 5 times 2. That's why we did 5 times 2. Now, Tessa, I'm going to show you something else that you're going to love. Are you ready? And if you don't love it, then I will eat my calculator. Okay? Are you ready? And by the way, I do not want to eat my calculator. So here we go. It's not very tasty.
Wait, have you ate it before?
No, but sometimes I think about it. Okay, you ready?
Yeah. Ooh.
What did I just do?
You made
Did
a
I just
spiky ball?
did I create another
Star. One.
another what?
Pentagram.
Yep. And
That looks like a star, but it's not.
well, no, it is a star, but it has a mathematical name. And Tessa, what did I just do?
You just made another star.
Now,
I mean,
Tessa,
pentagram.
if you start with a massive pentagram, you could keep connecting the inner points and make smaller ones and smaller ones until you can't see them at all. Now, the next one I'm going to show you, and this is, so can you read this word right here?
Hexagram.
Now,
I
based
need a symbol.
based on the number of points, can you tell me the meaning of the word hexa? Since penta means 5, because a pentagram has 5 points to the star, what do you think?
This one has 6?
Yes, it does. So what is the meaning of hexa?
Wait, isn't that one big triangle and then one hooked inside of it, kind of?
Absolutely. Tessa, do you know that you have just described a hexagram? That's how you create a hexagram. And guess who's going to do it together? We are. So here's what I want you to do. Take out your pencil. Now, believe it or not, some religions, I think Judaism and maybe Catholicism, use this particular symbol. And there's actually...
Got my pencil. Can I go get it?
Oh, please, please.
Under the table. Got it. Got.
All right. So here's what I want you to do. I want you to draw what is called an equilateral triangle. Now, equilateral triangle means that all the sides have equal length, and you may have to try a few times. Here's the way the word looks. Equilateral. Triangle. Now, the way you draw it is you kind of draw one leg, another leg, and a third leg, and you see if they look to be about the same size.
Or you can draw one arm, and one leg that goes sideways.
Wait a minute, Tessa, check it out. Tessa, look at my nose and my cheeks and my chin. Doesn't it kind of make an equilateral triangle?
Wait, yeah,
So-
and your nose looks like one. Our nose
Tessa-
looks like one.
Yeah, oh my God, Tessa, you're right. The nose is kind of like an equilateral triangle. Now you have a beautiful equilateral triangle because you have beautiful smile. See, the more beautiful your smile, the better is your equilateral triangle. Now, I want you to draw an equilateral triangle and show me what you've drawn.
One arm, a leg.
Oh my God, that's really nice. Now, Tessa, watch what I'm going to do now. I'm now going to copy that equilateral triangle and watch what I'm going to do.
You made it!
Wait a minute, almost. What? Wait a minute, I have to center it. I have to center it. That's not really.
It's kind of like an illusion because that one actually doesn't go behind it. It's like right on top of it.
So go ahead and see if you can draw the other one to really be superimposed, and you will have created a hexagram. Oh my God, Tessa, you're really good at this. So when you create a hexagram, and your parents are going to have to explain this to you because I don't know much about it, but I believe that some people call this a Jewish star or the Star of David, but I've also seen this star.
Wait, is it your name, David?
Yes, it is. And in churches, they also have these hexagrams. Now, if the hexagram has 6 points, how many sides?
My pencil fell again.
Well, then you should get your pencil.
Sorry, it keeps falling. Okay. Got nothing, so.
Okay, so Tessa, the question is, if a hexagram has 6 points, how many sides does it have? Now, remember the question I asked you earlier. The pentagram had 5 points, and it had 10 sides. So if that's true, Tessa, can you think of a fast way to count the number of sides of a hexagram?
Yeah. So both of them have 3. Because that one has 3. So 3 plus 3 is 6. So 6.
Well, we already know that there's got to be more than 6, because there are 6 points. Look at this, Tessa. 1,
Oh.
2, 3, 4, 5, 6. So there are definitely more sides than 6. But how many more? And what's the fastest way to calculate it? Of course, we could just go, how did you do that?
Because there were 6 sides on this side. So if we do it again, there will be more 6. So, and then I realized 6 plus 6, and then I remembered 6 plus 6 is 12. So then I said the answer.
Tessa, that's amazing. So you are correct. By the way, watch this. I just added on 1, 2, 3, 4, 5,
6
6, and 6 plus 6
equals
equals
12.
12. So a hexagram has 12 sides. Now, Tessa, you know what I'm going to do now inside this
You're gonna make
hexagon.
another and another until they
You-
disappear.
do you think I would do that?
Yeah.
Absolutely. Now here we go. You ready?
Yeah.
So you have to kind of skip, just like we did with the other one. You make your first triangle, and then you overlay another equilateral triangle, and you got another hexagram. And if you were kind of obsessed with hexagrams, like I hope you will become obsessed with hexagrams, you could make a green one inside there, Tessa. And then if you were like me, would you keep going?
Yeah.
You think? And Tessa, I would love for you to get big paper after we meet and show your parents and maybe other family members and friends how you can create hexagrams until infinity.
Is this kind of like an illusion because like it kind of looks like it's going under the other line. The line is going under the other line, but it's actually on top of it.
You know, I think the word illusion is a perfect word to describe what you're seeing here, because it kind of almost looks like you can go inside it. Like if you drop your pencil inside the little hexagram, it almost looks like you would lose it and you would never be able to find it. Now, believe it or not, and I do know a little bit about this because I have friends that are called Greek Orthodox. And guess what?
What?
They have a special gram in their religion. And let me show you what it looks like. It's called, just like your octopus, it's an octagram. How many points do you think it has?
6.
Really? 6? You know that a hexagram has 6 and a pentagram has 5. You know how many is an octa?
Oh yeah, 8.
8. So what we're going to do now is we're going to create an octagram. But who do you think is going to create it?
Me.
Me, I mean you. Now, here's what I want you to do, me, I mean you. I want you, me, to draw as good a square as you can draw.
Okay. Cause I have a cube in the corner right here.
Okay, good. Now don't make them too small, because the bigger you make them, the more fun we can have with them. So draw a nice size square. Very nice.
Another.
And now
Like
watch what I'm doing now.
Wait, can I try? I'm trying.
I want you to draw an equal size square and do the same thing you did with those 2 equilateral triangles. And then show me what you have. I can't see it very well, honey. Can you hold it steady and towards the camera down? Oh, wow. That is awesome. Now, Tessa, what I want you to do now is I want you to count the number of points on that star and make sure that we were able to do it correctly.
8.
You are 100% correct.
Because a star has 4 sides, and we put 2 stars in there, so that equals, because 2 plus 2 equals 4. 1, 2, 3, 4.
So if we know that an octagram has 8 points, and by the way, this is a special symbol in the Greek Orthodox Church. If you look at a Greek Orthodox church, and I love going to churches and temples and mosques, and if you look up at the ceiling, you can actually see an octagram on the ceiling. At least all the Greek Orthodox churches that I've been to have octagrams. So if you go into a church,
Been to?
what's that?
How many have you been to?
Oh, a lot, because every time I go to a new city, I like to visit temples and churches and mosques because I find them fascinating. Now, if there are 8 points in an octagram, how many sides? Now, I think that you've developed a method that is faster than counting by ones. Can you try your method, please?
Okay. What method?
You tell me. You use a certain method when you found the number of sides of the pentagram. Do you remember what you did?
Oh, yeah.
And then you use the same method when you found the number of sides of the hexagram. So I'm betting on you that you can use the same theory, and then we'll test it.
Okay. So sides. Let's see. There's 4 sides, so 8 sides. Same. So 8 sides.
Well, there's 8
4
points,
plus
as you know. There's 1, 2, 3, 4, 5, 6, 7, 8 points. So there must be how many sides? And by the way, I'm going to show you the 8 sides that are in the same position from every point. Now, if the red makes up 8 sides, how many more sides are there?
8.
Of course.
And
You
8 plus 8 equals 16.
and you, young lady, have just figured out the holy grail of grams.
That
Finding out how many sides an octagram has, just all you have to do is just double the number of points.
yeah.
So what if I had a decagram? Now, deca stands for 10. So how many sides would a decagram have?
10.
No, come on. If a octagram, 8 points, has 16 sides, then a decagram with 10 points has how many sides? Come on, every time you just have to
5
double it.
points.
You have to double it. You have to double
20
it.
points.
Of course.
I mean sides.
And 20 sides. And if you have a dodecagram,
Can you draw a decagram?
I kind of thought you would ask me that question, and I don't know if I'm capable of doing it, but you know that I'm going to try,
Yeah.
right? Okay, now do me a favor.
Yeah.
First, tell me how many sides has a dodecagram. By the way, dodeca means 12 points.
24.
Oh my God, you are amazing. Now, I'm gonna cheat a little bit here. I'm gonna try to find a decagram picture, only because oh, wait a minute. You know what I think we can do?
What?
I think you and we can use this. Okay, hold on, copy image. You and I are gonna actually learn how to make a decagram together. All right, what we're gonna do is we're gonna look at this picture, right? Now, what I'm gonna do first is I'm gonna create what's called a decagon. Can you say decagon?
Decagon.
Now watch this. Hold on a second. It's coming, it's coming. Here it is. And this has exactly 10 sides. Now what we're gonna do is we're gonna start by drawing a point. You see this point right here?
Yeah.
Do you see that point?
Yeah.
I'm going to connect this point to one of the other points. But before I do that, I'm going to number them so you can actually tell me where to go. So I'm actually going to number them with letters. And I want you to say, Mr. Kramer, I'd like you to go FGHI and then J. I'd like you to go from point A to what other point? So look at the figure and you're going to tell me how many to skip. So from A to where?
F. B. C. D.
Wait. Can you not guess? Like, look at this. Look at where the A is. It's right corresponding with that one. And look at where it goes. Or look at where it goes.
H.
And then from H to where?
To F.
Does that look right?
No.
Tessa, question for you. How many points did we skip from A to H? How many points did we skip?
2.
Yep.
So
how many
F.
points? F is only skipping 1.
E.
And then from
B.
E to where?
B.
Keep going, faster.
To J.
No, that only skips 1.
No, to I.
Keep going.
I. To G.
G only skips 1.
Oh, I to F.
Keep going, but no mistakes. This time you're just gonna say it right.
F to C.
Good, keep going.
C to F. No, wait. C to J.
Keep going.
J to G.
Keep going. And you only have 2 more.
G to D. D to nowhere.
Come on. Skip
Oh,
2.
D to B.
Nope, B only skips 1.
D to A.
Right. Tessa, look at what you did. You created a decagram. Okay. Now, the cool thing about a decagram is that inside of a decagram, you can create another what?
Pentagram.
But Tessa, I have a question for you. What would happen if we skipped, instead of skipping 2, we skipped 3?
We should find it out.
Tessa, you are a mathematician all the way through, because that's what, do you know that that's what mathematicians do? They
So like
always,
if they don't know the answer, they just figure it out by doing it?
they have to. They're like, they won't stop, Tessa, until they figure it out. So here's what we're gonna do. We're gonna draw a huge decagon,
Oh, decagon.
and then we're gonna create a, we're gonna skip though. We're gonna skip 1, 2, and 3. So I'm gonna have to number these again. And now I don't know if you can do this fast because this is hard, but I have all the faith in the world that you can follow this. This is very high level geometry.
Do you know it?
I don't. I've never done this before. So you and I are doing this for the first time together. We're, instead of skipping 2, we're skipping 3, and I have no idea what we're going to create. Are you ready?
So we're starting from G.
We're starting from A, and we skipped 3 vertices to G. Now we're going to skip 1, 2, 3,
G to
and go to C. Now you tell me where to go next, but count
to
before you
J.
answer.
C to J. No, wait.
Yeah, we don't
I.
keep going.
I to E. E to A.
Uh-oh. Look what we just created. A what, Graham?
Pentagram.
Oh my God, we created a pentagram. Honey, this is where we started today's lesson. We started today's lesson at a pentagram,
Pentagram.
and that's where we ended up. Now, I have a crazy idea. Okay, we're gonna start with a 7-sided gon. It's called a septagon. Okay, you ready?
Yep.
All right, so here we go. A septagon or a heptagon has 7 sides. All right. So, and it may start to rain here. So if it does, I'm gonna have to put you on hold for a minute and go inside. But I'm hoping that it holds out, and we'll see. So Tessa, can you try to draw a 7? So 1, 2, 3, 4, 5, 6, 7. Try to draw a 7-sided polygon, and I'll write the name of it. Pretty nice. Count the number of sides to make sure.
1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6, 7. Wait, that's only 6 sides.
Okay, so you drew a hexagon, which is still beautiful, but I like you to try to draw another one. Go to a new page and try to draw a septa or heptagon, which has 7 sides. And by the way, I'm going to clone this page so we can try this twice. Ooh, nice. Now, Tessa, we're going to start with 1. And I want you to tell me, you get to decide. Are we going to skip 1 vertex or are we going to skip 2? You
One.
can choose. Okay, let's skip 1. So say 1 to 6.
1 to 6, 6 to 4, 4 to 2, 2 to 7, 7 to 5, 5 to 3, 3 to 1, 1.
Wait. What have we created?
This one.
What's it called? A septa what?
Septuput.
A septagram. And if you created a septagram, isn't it true that it must have how many sides?
Must have 10.
Come on,
sides.
7 points.
7
You
points.
know you have to double 7.
It must have 5 points.
No, you have to double 7.
Um, 19.
Well, 7 plus 7 can't be 19 because when you double a number, it has to be an even number. And 19 is an odd number. Can you please try to add 7 plus 7 again, but be a little bit more
14.
careful? Exactly. So it has 14 sides. And can you believe that we created a perfect septagram? But guess what we're going to do now?
What?
We're going to end our lesson by creating another septagram. Are you ready? We're now going to skip 2 vertices, 2 points. We're going to go from 1 to 5, from 5 to 2.
2 to 7.
No, that's only skipping 1.
6 to 3. 3 to 7. 7 to 4. 4 to 1.
Guess what, young lady?
What?
You have just created a septagram that's completely different from that septagram. Isn't that amazing?
They're closer together.
I know, it looks so cool. So what I want you to think about is, how can you create beautiful grams? How can you learn about shapes? How can you relate the number of points of a star to the number of sides of a star? And that's what I'd like you to really focus on this week, because I think you can have a lot of fun with it. And you also learn how to double numbers. And then we can even start to talk about the angles and have so much fun. Now, can
Mr.
you?
Kramer,
Yes.
can we see, can eraser erase eraser?
Can an eraser erase an eraser?
Yeah, because I accidentally got pencil on it, so I'm gonna try and see. Okay.
Wow.
And
Maybe if you had 2 erasers, they would just disappear.
yeah,
What do you think?
it's still kind of here.
Awesome. Hey, kiddo,
Okay.
guess what?
What?
Guess what? I want you to create as many grams as you can this week. Is that a deal?
Deal.
Are you going to be a gram creator and a tessellation creator?
Yes.
And because they named it after you, Tessa. Tessa Lation.
What if my middle name was Lay and my last name was Tam?
No, I got it. I've got it. If you ever get a dog, you should name him Lation, because then you could say Tessa Lation.
My name is Tessa. The dog's name is Lisa.
Sweetheart, I will see you next week. This was so much fun for me, and have a great, great week. Bye, honey.
Okay, my dog says bye to you too.
See ya. Bye.